And then last week, we kind of defined a couple different events that will be associated with any kind of a transaction. So for instance, actually, let me see if there's a way I can show the model here. I thought you could do it. Okay, yeah.
Generated out of curiosity.
What's that?
Where did you get this graph? How did you get this?
Easy. So you just do.
Oh, from DBT?
Yeah, from DBT.
DBT. Oh, yeah, cool.
Doc-serve,
Awesome.
that's it.
Oh,
yeah,
nice.
Okay.
Nice. This will be public in the future when I finally get around to putting that on a subdomain. That's the issue from this.
And so you can look at this. Gives you the documentation here. You can see like the compiled query, right? So this was the logic that we were kind of working on, right? We now have 3 different types of on-chain events that we're tracking. All of them are going to be aggregated at the daily basis, like we did previously. We didn't do like a before and after, but this had like a massive savings in terms of storage and stuff like that. So it went from things being pretty much very expensive to being much more manageable now. So basically, there's 3 sets of events that we look at. Number 1 is the amount of gas that's been used. The second one is just any kind of transaction, and then there's one around a successful transaction. We'll probably build out a few more, for instance, like ones that are from a safe, originated from a safe, and then that would be like the from source ID, and then the to source ID would be the underlying contract that's in the internal transaction. In any case, that's an example of where these come from. And then let me just see how I get back. Okay, I'll just do it this way. Okay, so let's go back to the graph here. Okay, so we have all these different event tables. They basically all merge into the massive int events table, which is everything from on-chain to GitHub to NPM and any other future data source that we have. And then the main abstraction of that is one that just kind of looks at the events to a project that have some project identity associated with them. And then we bucket these by day. So probably there could be some optimization over here, but in general, this is now the main intermediate table that we're using for everything. I don't know how much of this you saw previously, but there was a bunch of other kind of intermediate models that were doing different pieces of that. I basically deprecated all of that. And so now we just have this like, pretty important events daily to project. And then you have a variety of metrics that are derived from that. So the other change here is that you have now like a on-chain metric with this prefix over here, and then you have the metric itself. So active addresses, active contracts, etc. And so as an example of what this one looks like, let's see the documentation. It is basically getting the address count for any project, and there's a set of time intervals that we've specified. So Ray, we can in the future extend this to any possible date combination, but for now it's like 30 days, 90 days, 6 months, something like that. And then the last thing is we use these to basically all these intermediate models get aggregated into this massive model here, which is basically just a huge union of everything. So we have all our metrics over here. We union them all together. And then the cool thing is that you can actually specify what time interval you want to grab from. So this could be days since first transaction, that's all time. This one we just care about 90 days. This one we care about all time. This one we care about 6 months. And so we can pretty easily add new columns here just based on these intermediate metrics that we've already defined. And so the same structure is replicated for the code metrics.
Cool. Yeah, this is great. I think we've talked about like wanting to do more granularity of like auto-generating things over time series or different granularity. So I think this is a good architecture to build off of.
And so we also have a version for the superchain for Optimism. So let me just share that quickly. And this one has the other cool thing about this. So let's take this model here. So in addition to having defined some metrics, these also have descriptions. So let's take the trusted daily active users. How did I get the description? Sorry. Oh, maybe not here. Okay, let's look at the description. Okay, so there we go. So you can basically see this is the schema description. And ideally, we can just auto-generate our docs from this being the metric ID, and then you have this description, and then you have all the time intervals that we've made the data available for.
Okay, cool. So this would be sourced in the YAML file that's associated with this model.
Yep, exactly. There's a YAML file somewhere.
Yeah.
I have too many tabs open, but that's where it comes from. Anyway, it's in there somewhere. I'll find. Oh, here we go. So this is it. And of course, the other cool thing is that this data is now live. So we can see it in production. What did I do here? Okay. So you can see all of the new on-chain metrics. These now have an event source, which would be Optimism. We could have this for Base, we could have this for Zora, we could have this for any network. You could then do an aggregation if you wanted to of all the event sources. But you can now see all the different metrics that we care about. We also have gas fees working properly. There was a little bug that Ruth and I discovered last week to get gas fees working correctly. But now these numbers match what other sources are saying. And we can also look at the retro PGF metrics, which are cool. These are different than the generic ones that we have. And you can really start to see differences between, like, I'll give you an example here. Let's look at gas fees. So the number one gas fee generating project is this one called Zen Crypto. Huge bot activity, only has 10 trusted recurring users, tons of transactions, tons of gas fees, but it feels very spammy.
Yeah, this is cool.
I guess that's it. Any questions?
Not on my side.
Anything from you, Ray?
So I guess, like, in terms of completeness of this data, I guess I do have a couple questions. Yeah, in terms of completeness of this data, is this like, if you had a score from a 1 to 10, like your confidence in these numbers, if that's even possible, what would you say at this current stage?
Yeah, I mean it's low, I'd say. But there's a couple dimensions. So dimension number one is these metrics are being built out. This is maybe 50% of the metrics that we'll have. So that part's not complete. In terms of the projects that we haven't done any updates really since RetroPGF 3. So basically, new contracts that have been released by projects that we track, we need to get those. I've actually done some analysis, and we're pretty close. I think we already have like 2/3 of them. So that's work that we can do quite easily. But then there's other projects that have since then.
No, totally. But I mean, registration hasn't happened yet, so that's reasonable. I actually meant more like how confident are you in the accuracy of this number, assuming we have all the artifacts for our retro funding 3 project?
Like the data is actually working.
Yeah, that these numbers are like correct.
I'm pretty. Yeah, I think there we're going to be pretty good.
Cool.
There'll probably be a few nuances with some contracts that like use a router, and so more of the things would be like an internal transaction. There's definitely be some issues around, like an example was, I can't even see it here. It's a project called Gelato, where they were getting credit for a lot of things that were really other projects just using some kind of resolver contract that they had. So there'll be kind of edge cases like that, but I think we're not far off.
2 follow-up questions. One is like, have we fully detached the Dune dump that we had, and this is all purely from the
Oh yeah,
Guzai?
there's no more Dune stuff in yeah.
Wow,
I think I may
amazing.
have deleted some of that stuff, but
Yeah, this is all new stuff.
Wow, that's cool. And 2, one of the things that I noticed last night was that like we are still putting in the artifact type into the artifact. So one of the things that we had discussed was like, hey, we wanted artifacts to what's it called? To have the artifacts be the same but tagged.
Right.
Sorry, instead of having separate
Yeah.
artifacts for each type. Did we ever like make that change in the model?
No, and it's still an issue. We had there was a big issue that I had last week that we had to fix. Remember that, Ruben?
Oh. Wait, was that wasn't is that related to why we had those counts right for the
Yeah,
wrong for the gas?
exactly.
Yeah. Because of the types. Yeah. So yeah, I guess if we grouped everything just by the artifact ID, because the artifact ID no longer considers type at all. So I think that is a way to get that.
Yeah, you see what's happening here, right? So these are all unique artifact IDs, artifact sources, etc. But like every variant of the type appears.
Yes.
That's
Which was originally expected, right? But now
Oh, okay, hold on. Sorry. This is interesting. You're saying that the artifact ID should be the same, even though you have different types, right? Because of the way we
yes.
calculate that macro now.
Uh-huh.
Um,
That's expected,
so
right?
yes. That
Okay.
is expected. So does that mean that
Cool.
like previously there was potentially a fear that we might count metrics differently depending on which type we're talking about. And I think what this tells me is that like we are calculating metrics properly now, right? Like as in um it'll be the same artifact ID, the metrics are attached to an artifact ID. So there's really no risk. Like we're the main thing here is that we are
We need to
effectively
ignore the type in like event aggregations and things like that.
Yeah, there's some stuff that's a little bit nasty.
Actually, if we had just ignored the type in the event aggregation, would that have simplified the change that you had to make, Carl? I'm trying to think now. I can't
Probably.
remember exactly what the solution was that we came up with.
Yeah, I
That
had
you
to
came
do
up with.
something. I'm trying to remember. Oh no, it was at this level, I think.
God, this is useful.
Where was it? Oh, here it is. Sorry, this is it. This is the thing that I did, which is very hacky. You see? So basically,
yeah.
it kind of looks at the artifact type and gives them a ranking, basically. And
I
then,
see. So I think, yeah, if we had just considered only the artifact ID, this would have worked without doing that.
yep.
Yeah, okay. Okay. Yeah. So Ray, as long as we only that's so you are correct, but we the aggregations aren't yet taking that into account in all places. So that's just a thing that needs to be done consistently, I guess.
Well, yeah, and the other thing is that we do use the events
We use it-
table to
Mhm.
discover artifacts.
Yes.
So
Which
int
can cause
event
problems. But yes.
gives us int artifacts history, which gives us int artifacts. This should be the other way around. We should have artifacts before int events somehow.
Yeah. Yeah. I mean, there is an artifact, like there's a table like that is apparent to int artifacts that I used in general just because, yeah, not using it, in the intermediate stage causes a lot of circular dependencies that DBT cannot resolve.
Yeah.
So, yeah.
I mean, I think ultimately we resolve it by having more of these types of things, right?
hmm
Like a staging model for deployers, a staging model for contracts, etc.
I think so. Yeah.
And
I mean, I think.
But this is where it gets messy. We have int artifacts by project, int events,
And then,
artifacts.
yeah, because the end artifacts history really does make that all kind of janky. Like,
Yeah.
huh.
Anyway, it's some technical debt that we need to clean up. It's okay for now.
Yeah, yeah. But the graph is useful for the visualization here, which also actually appears in Dagster as well. This graph.
Nice.
All good. I think I think what I'll do in the front end is ignore the artifact type column and assume that that might go away or change, right? And then it sounds like there might be a bug in terms of like the way it gets. If I ever use artifacts by project query in the front end, the same artifact will likely show up.
Yeah, don't do that.
Yeah.
All of these that reference artifacts, like they. Let me find a good example. Okay, just even like daily active users or something like that. They use the from ID. They completely ignore type, and anything that comes into these kind of events tables, remove type. So if you were to introduce that again by joining on the int artifacts, then yeah, you'd be getting duplicates.
Okay. Cool. I guess we'll have to figure out how we want to expose that in the API. But I guess
yeah.
the two options are you have like a type array or just change the column from a string to an array.
Yeah, that's kind of what I was thinking. Is like maybe we should no longer unnest it, right? Like just leave it nested as an array.
Or just have a separate one-to-many table for like that's just artifact ID to artifact type. That's probably the more canonical way as opposed to using arrays.
Yeah.
Cool. Okay. Anyway, just getting clarification. Thanks. I am super excited to see the Dagster stuff if Ruben's ready.
Yeah, I'm ready. Yeah, let's do this. All right, let's share the whole screen. Screens. There we go.
Ruben, you're like a bona fide data engineer now.
I feel like it. I mean, I guess it's it makes a lot of sense.
Like 99% of data engineering is just DevOps. It sounds like
that's exactly that's what I've discovered. It's just like, oh, data engineering is just DevOps with some worse tooling. So, no. They just need some love. That's all. Okay. So, I kind of tried to figure out how to structure this conversation here. So let's not do Dagster first. Let's actually talk about the Kubernetes setup. So, for that, really briefly, everything is going to be in the ops directory. Ops directory. For our Kubernetes setup, we use Flux CD. One of the reasons I chose this was that the setup was a lot simpler than I remember having done Argo. It was quite literally a one-liner for me, just running the Bootstrap. Once I allowed it to have admin access briefly. And so that was a big reason why I chose it, because I was like, oh, it's just running now. So was that the best way to make that decision? I don't know, but it's nice and convenient. We could always move to something else. There's nothing really stopping us. We're not using like a lot of bespoke things. So, but just a brief overview: stuff in the warehouse. This Flux system was auto-generated by that bootstrapping. So in general, I wouldn't touch things in this here unless you really know what you're doing. Yeah, like there's some stuff here about the Git repository that it follows. Like you can actually, the most important thing to know about in this part of the directory structure is that you can change this branch here. So if we needed to test, for right now, this is, what you would want to do is you would pause the Flux from like you would suspend Flux from pulling that data down every like 5 minutes, and then you would actually change the branch. I think in the future we might want to have it so that we actually do like tags for production, or something. Like we should definitely have a discussion about how we want to deal with like a staging versus production. But right now we're flying the seat of our pants. Everything's straight to production anyway. So, which is it's pretty cool. So. I do have a staging area for apps, but there's really nothing useful in there right now. This was just, kind of setting up some
So
infrastructure to kind of pretend that
can you
there's a
give me
staging area.
can you give me the 20-second version of like, hey, I'm Ray, I want to like add a new thing. Let's say, for example, I want to do self-deployed Hasura.
Yes.
I'm not saying
Yeah.
do that. Like,
So if
where
you
would I
wanted
do
if you wanted to do self-deployed Hasura, it would be fairly simple. So, okay, let's assume that you're going to be deploying into production because, we really don't have a staging area right now. Everything's defined in these Kubernetes apps area, and I'm going to be guessing that Hasura has a Helm chart. So I would be putting stuff into base first. So we use Kustomize and we use Helm kind of heavily with this current setup. So as you can see, these are three different types of applications. So there's the Cloud SQL proxy. I can talk about that briefly, but it's not super important yet. But essentially, like this pod info is just a test deployment, which is super useful. I used for a lot of the testing here, so I just kind of left it in here. But you would create a new directory. I would call it something like Hasura. And then within that, you can. So this customization is just a customized file. It tells, and this is one of the main things that that Flux will look for. And I'll show you where to tell it to look for that. But first, we'll just start here. Then you would define the, like the namespace for this application, the Helm repository, and the Helm release. And then this is sort of your base version of that. Then you would define that in production. And then, as you can see, let's look at the, actually, if we looked at the Cloud SQL one, staging, pod info, then you can actually just reference, sorry, this one's deeply nested, or not deeply nested, but
from this? Oh,
yeah. So this actually uses the base version of pod info, but you could rewrite things in that using Kustomize. So this one actually changes everything from base pod info namespace to staging pod info. So that's what this line does, and that's really the only thing that this specific customization does.
It says override.
Yeah, it's an override. Exactly. So, and then within each of these, you have a top level customization, and then the applications themselves have their own customizations. Hopefully that makes some sense. This just references like, oh, get Dagster and get Cloud SQL proxy, like install both of those two components. And then this is like customize with these specific values for production, which for Dagster is, actually not all that much comparatively. But yeah, and then the final thing to connect that all to the actual cluster is you go into here and you can see there's a productions app. Maybe I should have done this backwards, but yeah. So production apps. It depends on the infrastructure controllers because that's like sets up all the ingress, the secret management, all those other things. So just in case you destroyed everything and started all over again, this will initialize in the correct order. But yeah, so all it does is it auto discovers everything in ops Kubernetes apps production and all the, like all the customized files in there, and that's how it sets up everything. That make sense? It was quick. So, oh, am I still on?
Okay. You're running a little fast, but basically I need to add it to this production YAML
Yeah.
file.
Yeah. So hold on. Let me slow down a little bit here. Okay. So if we were to look at this Kubernetes apps, this right here, this path relates to this. And the reason why is your source reference, and this is like a very fluxy thing, is this Git repository. And the name of that is Flux System, which is, the main. We could rename this to anything, but that was when you do the bootstrap. Flux System is your root repository, which for us is only the root repository that defines all of the Flux clusters, which for us, because we're a mono repo, is just OSL. Does that make more sense?
Yeah, I think if it's not too much work, like literally a 10-line outline of like to add a new
Yes.
service in the README, like to add a new
Yeah.
service, make this file, do this, that.
Mhm.
Could be really helpful.
Yes, yes.
Yeah.
I will need that for myself as well because I know that I will forget these things. So I will definitely make that README. Yeah, that is.
Okay,
Yeah,
so let's say I made all these files. Like, how do I test locally? Is that like I can just read the Flux docs for that?
Yeah, so testing locally, the best thing would be to run if you actually wanted to test locally. It would be to use something like your own like Kubernetes kind or something like that, which runs Kubernetes and Docker. That would be the local test, which is the reason why I would like to set up a staging area, is because yeah, you just everything's GitOps, right? So it's all continuously deployed. So, yeah, it's not intended to be able to deploy via command line, right? There's no intent for that at all.
But how do I is there CI? Like, how do I know? Like, I can't just merge things to main and then cross my fingers and hope it works, right?
Yeah, so that is why I've had to change. So this is one of the parts of the workflow that I'm hoping to figure out a better way to deal with. Yeah, so that's why I've had to change this sometimes to a different branch. Because I was just deploying to main to get it to run up there. But yeah, I think the better thing to do would be to also be able to reference a second branch in here, and then you just deploy to that branch, and then that will deploy to like a staging area separate in Flux.
Okay, but
Does that make sense?
even in that process, you're still pushing the main constantly just to test. Is that right?
No. It wouldn't be to main. You would push to like your development branch or something like that, and it would run in staging or some
okay.
development area. Yeah.
Basically, the idea is that you just give up on the idea of ever running these things locally.
Yeah.
And
It's just so much. The problem is that running it locally, there's like a lot of other moving parts. So if you were to actually run all of this locally, and there's not a good way to do like, oh, conditionally, when you're on this kind of cluster, don't install this component, right? Which unfortunately is just kind of a sad thing with a lot of these toolings. There's not like, you can't do that kind of like uh, that kind of thing
Okay.
yet.
Well,
Yeah.
I mean, basically we should file an issue then on a staging area that watches, say, a branch called staging or a branch called dev or something like that, right?
Exactly.
That-
Yeah.
Okay.
Yeah. I mean, we're a small enough team that it's not going to be like we're not going to be stepping over each other very often, I believe. But yeah, there.
Yeah, I think
Yeah, I think for now this is the way that I would do it. Just because it is a lot to ask to like, hey, run Kubernetes kind and try setting this whole thing up local, which would be insane. I think.
okay, fair enough.
Potentially.
I will. Yeah, let me follow. Do we have an issue on that already, or
No, we don't have an issue on that. Yeah.
Okay. All right. Cool.
But
Great.
yeah,
Sorry for that. Yeah.
so a lot of the things, and again, a lot of what makes this kind of difficult to set up is we do have like cert managers, we have the Cloud SQL proxy, which actually needs to actually this specific one is no longer in use, but I would like to use it in the future. Our ingresses are all through Cloudflare. So none of the none of the cluster is actually exposed on the public internet directly. So everything goes through a Cloudflare tunnel. So all of that is described here. These are sort of like the base layer infrastructural things. And then we use GCS to do our secrets management. So, which, if you're to dig into that here, that just kind of, I'll write some docs on exactly how that is used. But there's some, essentially like it injects environment variables from our GCS bucket or our GCS, sorry, not GCS, our Google Secrets Manager, instance. So so that is Kubernetes. There's a lot here. There's a big like need to do a bunch of documentation for this. I would love to get to that in this sprint if possible. If we have the budget to put that in. But that's that. So next, Dagster, this beautiful beast, which took a long time to deploy because there was a lot of goofiness here. But okay, so the general thing about Dagster. So Dagster has a bunch of different components. I wrote these down for myself to remember. So there's the daemon, which handles like scheduling and like event, like responding to different events and things like that. So like these sensors are these aren't event driven, but you can have event driven sensors. So sensors are just like in response to some event, something happens. And these are actually cron based events. So these just or not cron based. Oh, actually no, these are real actual events. So these respond to runs of like the Gitcoin Passport or Karma 3 materializations, and they do some cleanup. But yeah, so the daemon is just the thing that handles scheduling for all of the materializations. Then there's the admin panel itself, which is this website. There's a read-only version of this, which has not yet been deployed. And then there's the user code, which you can see in this deployment. So this deployment is actually our code itself. So it pulls an image that we build in our GitHub Actions after every master or push to main, and then it deploys this and updates it. Which contains our code and all of the assets, that you can see here now. So and then finally, there are the jobs themselves. So if you run a materialization, which is a materialization is basically just, grabbing the assets, like this base blocks. If you materialize that asset, that means that Dagster will run the job to make sure that that table is up to date. That's all it is. But yeah, so those are the main components of Dagster, in the Dagster deployment. Some things about that, and maybe some important stuff about our cluster is we run some very small nodes, or as small as was able to manage it, to run our persistent containers. So these are things that shouldn't restart randomly, or should not restart randomly as often as to the best of our ability. And then there are spot nodes, spot instances, and preemptible instances that run these jobs. So we can save as much money as possible here. And then so the jobs are actually by default they're scheduled on spot instances. If for whatever reason you create an asset that needs to be scheduled on something that's more reliable, that's something you can define inside the code itself. So, but if there is no definition for a specific asset, it will just run on a spot instance.
What is the controller that will spin up and tear down spot instances in response
Oh
to
yeah,
these jobs?
so GKE just comes with a an automatic it has automatic scaling. So by default those spot instances are set to like 0. And then the main thing that you have to do when you want to schedule a pod onto one of these instances is you have to give it a toleration. And the toleration is just it's like this tag that you add to a pod that says, hey, I can run on a spot instance. And then you also put a node selector which says, hey, run me on a spot instance with this number of resources. So the important thing for all of our auto scaling is that as best as we possibly can, all of the pods that run on the system on Kubernetes should have resource allocations and resource requests. So like a maximum number of a memory limit and a CPU limit, and then
let's say I'm creating a new Dagster job. Like, where am I doing that?
Oh yeah. So if you wanted to do it for a new type of asset, so you do it at the asset level or the operation level. So we don't yet have any ops that are separate from assets. Everything that we do is just asset based right now. But an op is just like a random job that you can run. Like it'll just run code, any code that you want. But within that, there's a decorator in Python, like at asset or at op, and then that can include basically your Kubernetes configuration if you really needed a special one for that specific asset.
Oh, interesting. Okay, so this should be part of the Dagster docs then. I should be able to find.
Yes, it's in the Dagster docs. Exactly. Yeah. So it's all built in. So yeah, they have a Kubernetes run launcher, and that will grab that metadata information from each asset.
Got it. I think I'm having a hard time. Like, I'm trying to map.
There's a lot.
I'm trying to. I understand how it works in principle. Like, that's not the part that's confusing. I think the part that's confusing for me is like, what is built into Dagster, and
what are we doing custom?
And what are we doing custom, and what do I need to modify if I'm adding a new asset, right? And so
yeah, I think actually, so the current setup I would say is we don't do anything in terms of like job scheduling or anything like that. That is super custom. So all of it is basically out of the box, like batteries included features that Dagster has. So we haven't done anything that's too insane yet. I do include a way to call something called Dask, which will do the exact same thing as Dagster in a lot of ways for for creating additional Kubernetes containers. That's if you needed to do massive parallel processing on a single thing, which is or on like if you needed to do like a giant MapReduce like that, you can use something like Dask, which will also automatically deploy to our Kubernetes container. But that is the only custom thing that is in there, but it's actually not even in use. But I left the code in there because I used it at one point. And I figured
Maybe just to make this,
I can do that.
maybe just to make this live stream a little more concrete, but could you walk through like,
Mhm.
okay, here's an existing job end to end. Like, how
Yep.
do I monitor the current status of it, and how do I trigger
Mhm.
individual stages on that pipeline? And then maybe separately after that, like if I wanted to add a new stage or a new asset, like roughly, what does that look like?
Yeah. So yeah, let's just go over it. We can choose one of these to materialize. The Zora stuff was last materialized last night around 10. So yeah, let's do that. It should be quick. The blocks should be fast. So yeah, I took this down from an hour to about 10 minutes, I think, for each of these, so which is great. Um yeah, so when you want to materialize something, you basically sorry, that was too quick. All you have to do is go from this this menu item here and then just hit materialize. I'm not going to hit it again. There's actually if there's one thing to note, right now if you materialize something, don't try clicking it a bunch of times. The UI might not be responding well, and if you schedule multiple jobs at once, I actually don't know yet what happens for like if I had multiple Zora blocks jobs running at once. I don't think that would work properly. And so, yeah, so that would be the only thing. But there are some settings in Dagster that I can prevent like multiple runs of the exact same job. It's just that I didn't put those in yet. So that's one thing to note. But yeah, and then what we'll see here is it'll be very slow for about a minute if there's no other jobs running, and the reason is. So we're gonna look at Kubernetes. Is actually so a new node is being spun up, and that's this spot instance. And then now, yeah, that spot instance actually just initialized. So now we're waiting for the pod itself to initialize. So, oops. So that's what this is. This Dagster run. So if you look in our Kubernetes, and if you don't know what this tool is that I'm using here on the right, that's K9s, which is super useful. Um, yeah. Um, but it's yeah. Now the Dagster's running. It should get logs. Some of the event logs will go into this little section here of this run. And if you, for whatever reason, like can't find the run, all you need to go is you just hit the runs here on the top, and this will show you the jobs that are either have run, have failed, or are like in this instance starting. So we're still waiting for this instance to start.
Do you mind showing
Yeah.
a couple examples of a materialized result of like what
Yeah.
track progress?
Yeah. So let's see. So let's look at like different types here. So when this is done, whoops. I guess maybe the admin panel. Ooh, why did you fail? No, well, that's not my code. So let's take a look at a different one. Okay, cool. Yeah, I don't know what was going on with that. So yeah, the Frax transactions. Let's see. So this completed. This actually doesn't have much of a response right now. These jobs don't respond to anything other than like success or failure. So it's just a Boolean: is it done or is it not done? But the asset itself, yeah, you can. There is so right now, one of the things that we don't yet do is give any sort of like metadata on what happens in each of the asset materializations, but that's actually something we could do, and I probably will do in the future. But for right now, it is just like a Boolean. So, but if there was anything that would show up, it would show up at the end of this run, and it would show you like, okay, the materialized asset has these specific statistics, and you would, in order to do that, when we define the Dagster job, we would use this object called materialized result.
Okay, I think there's enough to get started. There is this issue 621, quote unquote, data completeness dashboard, which I think can just repurpose that to just be like update, like, actually expanding on the metadata that's returned in materialize
Exactly.
result.
Yeah. Exactly. I think that's the only way that we'd be able to do that here. I mean, you can call the GraphQL query, and we could maybe like summarize those things in a different place, or even export that into BigQuery for ourselves, right? As just part of another materialization in Dagster, so that we can get like but the dashboard itself does not show like so the kinds of things that Dagster does not do. It won't be able to tell you like it assumes that your job's complete, and then that is it, right? It doesn't have a notion of like um of like how well it completed, unless you give it some semblance of that. But it also doesn't have like, if we were to put that metadata in here, it doesn't have a way of representing it that I'm aware of. So but one of the other things that you can do, so for each, one of the things I would love to be able to do in the future, and I was just reading about this, is if we separate a lot of these things into different partitions, we can show different partitions failing for each of the materializations, which could be useful, right? So when you run a materialization for today, let's say the partitions are every day, if that fails, that would show up as like a red mark here somewhere, right? So,
Well, I think the other thing is like, how do I visualize data dependencies? Because let's say, for
yes,
example, I materialize an asset that's somewhere in the middle of my pipeline. Well, it's working off of stale data, right? So even though it's a green check
yeah,
mark, and I see the date is recent, it doesn't actually mean what I think it means.
yeah. So one of the things, yeah. So wait, you're wondering how you can know about stale data and like the data dependencies and stuff?
Yeah,
Is that
basically.
correct? Yes. So
I mean, like if I want to materialize something in the middle of my pipeline, I actually have to like start at the left end and then propagate each run all the way through, right?
yeah, so actually from any given, so unfortunately, like this is I just made an issue for this to actually connect these directly to the DBT. So as you can see right here, everything on the left here is all the superchain data, right? And then everything on the right is all the DBT stuff. In reality, or when this is all working properly, like base blocks would actually be connected properly in this DAG. Does that make sense? So it's just not currently connected there, but it should actually show up as like as an item in this DAG related to DBT. And then what you can do is, let's say we look at int artifacts by project. You can actually, if you go to the lineage tab, you can see the upstream and you can see the downstream. And then you could materialize all the things from here if you needed to do that level of
Can I just say
granularity.
can I materialize everything upstream,
Yes.
or everything downstream, but just that subset?
Yes. So it says like right here, there's a materialized unsynced. Like you could run that. I haven't run anything for DBT here yet. Mostly because the other DBT job is still running. But once I disable all of that, like all of this will be connected properly to that.
And
But
materialize all, when you do materialize all there, is it smart enough to know, hey, do the things that are, top of funnel first and then the next stage and then the next stage? Or does it
yes,
like
it,
just
it does. It does
unsuccessfully
understand the DAG.
put it
Yeah.
all at once? What
Yeah.
is
So
unsync?
it won't. It'll if they're unrelated, it will run all of it. It will. It can run those in parallel. But that is handled by DBT itself in that specific case. But when you select like where we were before, if you were here, and yeah, you wanted to materialize all of this, like all of the upstream and downstream, it should handle all of that
Yeah, because
in
it's
the
not
correct
always
order.
like it's not always DBT relationships, right? Like you might have a
Mhm.
relationship to some other software-defined asset that's a data source, and you also want to make sure you
Yes,
run those jobs first.
exactly. Yeah, so like let's say for whatever reason, like we had the Cloud SQL stuff in here, like that might appear eventually, right, in this in this downstream, like as a downstream asset, right?
Yeah. Upstream
And
asset?
then if you were to run materialize all, that would eventually get copied straight into Cloud SQL.
Oh, Cloud SQL. Yeah. Okay. Got
Yeah.
it. Cool.
Yeah.
Yeah.
So like this is the Mart, right? And then the Mart connection should be into Cloud SQL, but that doesn't yet appear here because we just don't have all of that configured yet. So there's some work to be done for the configuration here, but yeah, once all of that is available and ready for us to use, that should be possible, or that is how it is intended to function. And then the other thing you can do is for each asset, you can set like a freshness policy, right? So a freshness policy is like, okay, well, if it's older than 24 hours, make sure it has a materialization. Yeah, and so those are all like the Dagster daemon ensures that those things, those declarative things about your assets are always true. But if you needed to do like a one-off, yeah, like this is how you would do it. You would have to go in manually and then materialize everything.
Got it.
Hmm.
Cool. This is
But yeah,
exciting.
it's a cool tool. You know, there's a bunch of stuff that we still need to do, but it's definitely like this is a self-service, you know, is what I'm running towards. So yeah.
Cool. Sorry, I didn't mean to like totally commandeer all the questions.
No,
Claude,
no,
did you
no,
want
no.
this? Because I feel like it's equally important for you to feel comfortable with this.
Yeah, I'll probably have to watch the video a few times to answer that. But
Yeah,
so,
there is a lot. There's a lot here. Turns out we got a lot done this sprint. So yeah.
Yeah, this is super cool. Super cool. I'm excited. I feel like this is going to be a big step up.
Yeah, yeah.
Wasn't
I'm also
totally.
very excited.
You remember I was not totally sold on this, but like seeing it live with all the complexity, like, yeah, it's pretty
It's pretty
interesting.
nice. It's pretty nice. There are some things that we're missing that like are only in the paid for product. I don't think we actually need them. You know, I found some stuff that we can do without it, but if we find we need that, then you know, I already asked I already started a conversation with the Dagster like commercial side just as a curiosity. So I'll let you know if there's anything, but it's mostly around like alerting and stuff. So that's all their paid for product. But I actually realized we can do those via sensors and just have that be like straight to Discord or something. So
Since we
yeah.
were just talking about like materializing it into Cloud SQL, um, crazy idea. Uh, how hard and or what roadblocks or hiccups do you foresee if we wanted to try leveraging this new flex capacity to spin up a self-hosted ClickHouse and copy into the ClickHouse instead?
Oh my god. uh, so we could do it. Um, I would want to set up a different kind of node because the nodes that we have that run that are persistent are very small.
Yeah. Yeah, this would
Yeah.
need to be a little beefier and it would need a lot more storage, probably.
Yeah, it would need to be beefier and it would need to have the persistent storage set up. So there is like, yeah, there's another day worth of like, okay, well, we got to configure the right disks and stuff like that for that. Maybe not another day, like just a few hours of that. But yeah, it's just annoying.
Yeah.
But yeah, I
Not me. I
mean,
feel like this would
it's
probably be
definitely possible.
for we remember we filed that issue on um what's it called? Populating all the universe of artifacts, right?
Yeah, yeah.
Um and that's like generally the direction of that side of things. So it's not immediate. It was just kind of like a nerd snipe question, but like,
Oh yeah, I mean, I think it's actually faster for me to deploy Trino than it would be for me to deploy ClickHouse.
fair enough. Yeah, fair enough.
Yeah. Well, maybe not,
And
but yeah.
I was reading the BigQuery docs the other day, the pricing docs, and I don't know if I'm reading it right, but like, am I right in believing that the BigQuery storage read API is free if you keep Trino in the same region?
Yep. It is. That is exactly why I've been trying to push for Trino
Cool.
in like a design, or not pushing for it, but like I'm designing that with that in mind.
Yeah, you're
Yeah,
probably right. That's the right way to go. Cool. That's
because
exciting.
because I think it keeps, it keeps all the things that we want in terms of like public access to our data, but then
Yeah.
also then we have our compute runner, right, which we don't actually run all of our DBT stuff very often. So yeah, and then writing back into a table, as long as we write it first to GCS, is not expensive.
I mean,
Right.
there's also a world where we actually like no longer need the Cloud SQL thing in the future if we do it that way, right?
Exactly. Yeah. Yeah, because then we would just run like small queries and stuff from something else. Yeah. So
Yeah. Yeah, that would be really
yeah,
cool.
yeah. I mean,
Wow.
hey, you could do that all with that is definitely fit into something like DuckDB, right? Like you wouldn't necessarily need to spin up all of the Trino coordinators to do that, right? So yeah.
Uh, DuckDB? How would you
Yeah, you
load it
can
into?
run DuckDB like so if we needed to, you would just stream all of the stuff from BigQuery into DuckDB and then just, serve that. So,
Well, okay. I mean, but at that point, it's no different than loading into ClickHouse, right?
yeah, I guess that's the same. Yeah. Yeah.
Um, cool. All right. Well, that was super cool. Thank you for sharing. Yeah, Carl, did you have any other questions, or you feel like you just need some time to process?
Yeah, I mean, I think that it's great to see. I don't know how much is like going to intersect with stuff that I'll be trying to do in the near term. It's just good to know that that's there, and won't
Yeah,
have
I
to.
think my big hope for you, Carl, is mostly like if for whatever reason you ever feel like, hey, data's like not fresh, like all you need to do is come in here and like click materialize. Like that
Yeah,
would be my hope.
yeah, no,
Like,
that's pretty straightforward.
yeah.
Yep. Yeah, I think from that perspective, like prioritizing the metadata into materialized view, like the status reporting, that kind of stuff, and then making sure that like all the DAG dependencies are properly connected from the source into DBT, but also from DBT into Cloud SQL, like
Hmm.
um, just cleaning that up a little bit, just so that like yeah, it can be really fully self-serve if Carl wants to like materialize any fraction of our DAG,
Yeah, yeah.
in a sense.
Yeah, totally. Yeah, I need to make another issue for this, but I think what I'd like to have is, all of the DBT things, including the playground, like our like canonical playgrounds and stuff like that. So that way the entire universe of the DAG that we control is within here. So, um,
Yeah. Yeah, magic. It's like God mode for data. Pretty cool.
yeah, it's cool, man. I really like this tool. So, I'm very happy that it's I wasn't sold on it either at first. I was like, I don't know, this is a lot of complexity. And then once I sort of grokked everything, I was like, oh, okay, it's not that bad. Really not that bad.
Cool beans. Well, thanks for joining, everyone.